Hey, welcome to the next video in the series. So in the last video, we calculated the points on the globe. So we initially were given 2 points, A and B, and we were asked to calculate the distance between these points, right? So we converted these latitudes and longitudes to northings and eastings. We also converted these northing and eastings to Cartesian coordinates. So we had an X, a Y, and a Z component for point A, and similarly for point B. And after we've done that, we are ready to calculate the angular distance between these 2 points. Okay, so angular distance meaning that we're measuring basically the angle from the center of the Earth to point A, that angle from that line from the center of the Earth to A to the center of the Earth to point B. Okay, and so the way in mathematics that we calculate the angle between two vectors is we take the dot product of these two vectors here. Okay, so this dot in the middle here, this is not your regular multiplication. And A and B here, these are not numbers, okay? A is actually a vector made up of 3 components, AX, AY, and AB. You can think of it as a list, okay? AX, AY, AZ, dot product with the vector B, BX, BY, BZ. Okay, and so this dot product is equal to the cosine of the angle between the two vectors, okay? So the way we calculate this dot product is we take the x component for A and multiply it by the x component of B, add to that the y component of A multiplied by the y component of B, I'm not sure why that's a different y, add to that the z component of A multiplied by the z component of B. Okay, so we can calculate that dot product quite simply, and that gives us the cosine of the angle. Okay, so that's not quite what we want, because we want the angle itself, this delta here. So to calculate the angle itself, we can take the inverse cosine of both sides of this formula. So the inverse cosine of the cosine of delta just gives us delta. So that's what we want, the angle. The inverse cosine of the dot product of A and B can be calculated like so. Okay, so what we're going to do now is use Python to calculate this, this angular distance. Okay, so we've back to our code from last time. We have our convert to northing, convert to easting. We have the definition of our 2 points, A and B. We convert these points A and B to northings and eastings. We convert these northings and eastings to radians, because previously they were in degrees. And then we applied these formulas that we introduced last time to calculate the Cartesian coordinates of each of these points A and B. Okay, so what we need to do is calculate this angle delta. Okay, so there's 2 parts of this. We had to calculate a dot product of A and B, and we had to calculate the inverse cosine of that result. Okay, so let's have a look. Okay, so this thing delta, okay, so the inverse cosine in NumPy, it's very easy actually. It's just NumPy dot arc cosine. So arc cos is just the inverse cosine. Okay, so the inverse cosine of what? Well, the inverse cosine of the dot product of A and B. Okay, so again, we're going to make use of NumPy here, which we imported at the start. We're going to make use of NumPy because we can write np dot product, so dot, and then in some more brackets, we can write the 2 vectors that we have. Okay, so vector A is AX, AY, AZ. So these 3 values here form the vector A. So I've just made this into basically a list or an array. Dot product needs 2 vectors, so I'm going to press comma. Again, square brackets, BX, BY, BZ. Okay. And so now just to check out what the value of that delta is, I'm going to print that. Print. Well, let's go angular distance equals plus str delta. Okay, let's see if that works. Okay, so the angular distance is this thing, 0.8935. Remember, this is still in radians, so this is basically 0.9 radians. Okay, but maybe we want that measurement to not be in radians, so perhaps we want that in degrees. So let's say deg for degrees, deg distance. Okay, so now what I need to do is convert this thing delta from radians to degrees. So I'm going to use the NumPy function here. So NumPy rad to deg delta. So again, you can use the function that you wrote earlier in the class. So angular distance in degrees. So I'm just printing out here this angular distance in degrees. Okay, so now if I've taken my angular distance here, delta, and I've converted it from radians to degrees. Then here I'm just printing it. So if I save and run this, then I get some error because I've done the wrong thing. Rad to deg. So rad the number 2 rather than spelling 2. Let's try that again. Okay, good. So that angular distance of basically 0.9 radians is equal to basically 51 degrees. Okay, good. All right, but the last thing we might want to do is, well, I don't know about you, but if you give me 2 points on the globe and you tell me that there is 51 degrees between them, it doesn't really mean too much for me, to me. What I really would like to know is how many kilometers that is. And so it turns out that approximately for every 1 degree on a globe, that is roughly approximately 111 kilometers. So what I'm going to do here is define a new variable called, which I'm just going to call distance, and I'm just going to set this equal to the distance in degrees times 111. So 111 kilometers. And again, I'll just print that distance. Distance in kilometers. Okay, so let's run that code and see what it says there. So apparently between my point A and my point B on the globe, given by these latitudes, longitudes here, that distance being 51 degrees or so is approximately 5,700 kilometers, which seems like a long way. Okay, so what I think you're welcome to do and to try is to perhaps try different values of latitude and longitude. Perhaps you could look at the distance between Palmerston North and the South Pole, for example. So have a go at that. And next time we'll look at making this distance calculation into a function. So all these steps, we want to be able to repeat this for as many points as we choose. Okay, so we're gonna functionalize this code very soon.